The general meaning of the word pitch means a constant distance. So now what the constant distance or why the constant distance is incorporated with the word pitch means, so it is this constant distance in case of a screw gauge is, it is a distance between the two consecutive threads of a screw. We know that in a screw there are multiple threads. So suppose there are 10 threads are there in a screw. Already you may know, I think that you may all of you saw the screw. There are 10 threads are there. What is the distance between first thread and a second thread, second thread and a third thread, third thread and a fourth thread, like that? Definitely it is a constant. This constant distance is referred as a pitch. But what is that constant distance in your screw gauge is a question. So how to find that constant distance in your screw gauge as, so now you can define that constant distance, that is pitch, in your screw gauge as a ratio from distance uncovered on a pitch scale, distance uncovered on pitch scale, of course in millimeter, to the number of rotations given to the head, So you just imagine that in your screw gauge, the 0th division of the head scale coincides with the baseline of the pitch. Now if you rotate the head, if you give the rotations to the head of the screw such that 0, 90, 80, 70, 60, again 0 will coincides with the baseline of the pitch, then you can say one rotation is completed. So when one rotation is completed, you can watch how much distance is uncovered on your pitch scale. So suppose in general you can give plenty of rotations. Suppose you can give 10 rotations to the head of your screw. When we give 10 rotations to the head of the screw, now watch what is the distance uncovered on the pitch scale. So if the ratio of this simplification gives the value of that constant distance. If in your screw gauge there are 100 divisions are there, you are going to give the 10 number of rotations. In such a screw gauge, the pitch scale is graduated such that the value of one pitch scale division is 1 mm. In such a screw gauge, if you give 10 number of rotations, there may be a 10 mm is the distance uncovered on the screw gauge pitch scale, and number of rotations given to it is 10. So this 10 gets cancels with this 10. Now the pitch is 1 mm. So this is the case in case of a screw gauge where the value of one division on the pitch scale is 1 mm. Instead of this, suppose in the pitch scale of the given screw gauge, the pitch scale is graduated in a way such that the value of one pitch scale is half mm. In such a screw gauge, if you give the 10 rotations, the distance uncovered on the pitch scale is again a 10 divisions, but value of each division is half mm. Therefore, distance uncovered is 5 mm. For 10 number of rotations, you can take 1 by 2, it is half mm or 0.5 mm. So in general, the pitch, that is the constant distance in your screw gauge, is equivalent to the value of one division on the pitch scale. This is how the pitch of a screw gauge has been calculated. So you just imagine that in our screw gauge, the value of pitch is 1 mm and there are 100 number of head scale divisions are there. So you can simplify this one, you will say this is 0.01 mm or this is 0.001 centimeter is the least count of the given screw gauge. So this part is very important. Once when you take the screw gauge, first thing you have to watch is what is the error which is incorporated in your screw gauge, correct it, then find the least count. To find the least count, first calculate the pitch. So, to calculate the pitch, you can give any number of rotations, there is no any restriction. Usually the value of the pitch is equivalent to value of one division on the pitch scale. After knowing the value of the pitch, so using the equation pitch divided by number of HSD, you can get the least count of the given screw gauge. Then how to note down the pitch scale reading in case of a screw gauge? So, whatever may be the type of the dimension, I mean you are going to find the thickness of the given object, you are going to find the diameter of the given object, anything etc. So, you have to hold that object in between stud or fixed plug and the movable tip of the screw like this. So, you have to arrange the free space between the fixed plug and movable tip of the screw and given rotation to the head of the screw unless until object has been firmly gripped or ratchet sound has been heard. Once this process is completed, arrange the screw gauge parallel to your sight. Observe what is the distance uncovered on the pitch scale. So, you have to write down, so the pitch scale reading. So, in this case the pitch scale reading is, so you may not visible, I will say it is 12 mm. So, how to note down the pitch scale reading? After the object has been firmly gripped between the fixed plug and movable tip of the screw. So, try to observe the what is the distance uncovered on the pitch scale, that is the pitch scale reading. Without disturbing this position, what is the division on the head scale coincides with the pitch line. So, here it is 63, head scale reading it is 63. So, before that we have a what is the error and what is the correction. Imagine that in my screw gauge the zero correction is plus 5 HSD. Least count is 0.01 centimeter. Then how to write down the total reading? What is the thickness of this object is? This is pitch, it is 12 mm. So, you can write it is 12 plus head scale reading observed is 63. So, correction is plus 5, it is plus 5 into least count is 0.01 mm. Observe here. So, I will take the pitch scale reading in terms of the millimeter, that is why I will take the least count is also in terms of a millimeter. Now, it is 12 plus 63 plus 5 is 68 into 0.01. Now, it is 12 plus 0.68. Now, it is 12 plus 12.68 mm, or even you can say total reading is equal to 12.68 mm. If it is in centimeter, it is 1.268 centimeter, like that. So, this is the way of having the total reading in case of a screw gauge. So, by following this convention, so you have to done some experiments on the screw gauge which are prescribed for the applied science lab. So, observe here in an ordinary scale, so the least count is only 0.1 centimeter. So, in case of a vernier calipers, the least count is 0.01 centimeter. So, and in case of a screw gauge, so it is 0.001 centimeter. So, in the ordinary scale, the least count is 0.1 centimeter, and in a vernier calipers, the least count is 0.01 centimeter, and in case of a screw gauge, the least count is 0.001 centimeter. But we know that, so vernier calipers is more accurate than the ordinary scale, and screw gauge is still more accurate than the vernier calipers. So, you know the result and you know the least count of all these three measuring instruments which are used very frequently. Now, the question is there any relation between least count and accuracy for a measuring instrument. So, by observing these set of values, you can say as the least count decreases, the accuracy increases, and vice versa is also true. So, you can remember this in the form of a the relation between accuracy and least count can be given as, so least count is inversely proportional to accuracy. As the accuracy increases, least count decreases, and vice versa is also true. So, this is how, so the relation between least count and accuracy has been studied. So, with this I stop my the discussion on the measuring instruments. So, in the last of my session I will solve some problems on the measuring instrument. So, before that we concentrate our interest on starting the second chapter, which is the force and linear motion. Force and linear motion. Definitely this is a chapter belonging to one of the basic branch of a physics, which is a dynamics. So, I mean dynamics is a branch of physics which deals with the study of the material bodies which are under motion. Broadly, dynamics is classified into two important groups, namely, so kinematics and kinetics again. Kinematics means again it is a branch which deals with the study of the motion of the bodies without referring the cause for its motion. So, for what reason the body is under motion, not interested, only the thing is the properties of the bodies which are under motion. In a quite opposite sense, kinetics deals with the study of the bodies which are under motion and also interested in cause for its motion. So, now in this chapter the word linear motion means, usually if a body is under motion, there are two types of motions are possible in general. One is the rectilinear motion, another one is the circular motion. So, here rectilinear motion or linear motion means a body moves along a straight line without changing its direction, or if a body moves along a straight line, then it will be referred as a linear motion. Throughout this chapter, if we say if a body is under motion, it understood that that body moves along a straight line, or that kind of a motion is a linear motion. With respect to your syllabus, the circular motion is not included. That is why you just think that if a body is under motion, that body moving along a straight line. Now, what is a force? Force has many definitions. Suppose if there is a material body in front of you. So, if you apply some force on it, the body starts to move. So, in a quite opposite sense, suppose a material body so moves in front of you. If you apply some force on it, definitely that body stops. You just analyze these two examples. In the first case, originally the body is under rest. By applying some force on it, the body starts to move. In the later case, the body is already under motion. By applying some force on it, you may change its direction, you may change its magnitude, or even you can stop it. So, for these two, in these two examples, we are applying some invisible, a fictitious physical quantity that is called as a force. With respect to this example, you can say force is an external agent which can change the original state of the body. So, usually the original state of the material body can be say in the form of rest and motion. So, even in a single sentence you can say push or pull is referred as a force. Now, one of the familiar definition for the force is a external agent which can change the original state of the body. So, original state is rest and motion. What is rest? You can say if a body does not changes its position when compared to its surrounding material bodies, surrounding moving bodies, then corresponding position of a body is labeled as a rest. Similarly, for a motion you can say if a body changes its position as time passes when compared to its surrounding stationary bodies, then corresponding position of a body is labeled as a motion. So, rest and motion are the two original states of the body. So, before going to discuss the further concepts under the chapter force and linear motion, there are few definitions on it. So, we can study one by one. What is the meaning of a distance? So, you say distance means it is a physical quantity which gives the meaning for how much of quantity of motion made by the moving body. So, in a word you can say distance means quantity of motion. With respect to mathematics you can say distance means gap between any two points. Here one more physical quantity which is analogous to distance, which is referred as a displacement. What is a displacement? So, it is almost similar to the word distance. You can say displacement is distance travelled by a body in a particular direction. Here with respect to the difference between distance and displacement is, in case of a distance, gap between any two points, I mean irrespective of its direction. Here there should be a specific direction between the 2 points. So, you should know which is the initial point, which is the terminal point. I mean you can say in a single sentence the distance between the distance travelled by a body in a particular direction should be labeled as a displacement. The unit and dimensional equation of distance and displacement are one and the same. Now, let us imagine that the body is under motion. If a body is under motion, so time is a variable physical quantity. Along with the time, so when the body is under motion, distance also changes along with the time. Now, is there any relation between distance and time for a moving body? Definitely. So, that relation should be expressed in terms of one of the physical quantity which is called as a speed. If a body is under motion, you can say with what speed that body moves. So, how can you define, how can you came to know the magnitude of a speed? It can be defined as a ratio of distance travelled by a body, ratio of distance travelled by a body to the time taken by a body to travel that sort of a distance, but not giving importance to the direction. We say distance, it is not a displacement. Distance travelled by a body in a given time without referring its direction, you call it as a speed of that moving body. In general, suppose if a body covers a distance of 30 meters, if a body covers a distance of 30 meter by consuming a time of about 10 seconds, then you can say, so you can say 3 meter per second is the speed of that moving body. So, you just remember the distance travelled by a given distance travelled by a moving body in a given unit to time irrespective of the direction is referred as a speed, because here we are not giving the importance to the direction. That is why you can call speed as a scalar quantity. Suppose if a body moves along a straight line, or if a body moves in a particular direction, then the same definition, what is the distance travelled by a body in a given time, we can't say it as a speed, but it as a velocity. So, the difference between speed and velocity is only the things. So, in the first case, that is speed, the distance travelled by a body without considering the direction. In the second case, here also we are interested to calculate what is the distance travelled by a body by giving importance to the direction also. Distance in the presence of a specific direction, you call it as a displacement. Therefore, you can call velocity as a ratio from displacement made by a body it's a ratio from displacement made by a body to the time taken by a body. Only the thing is, here it is a without considering the direction, here it is by considering the specific direction. That is the only difference, rest of the thing is one and the same. So, you can say velocity as a ratio of displacement made by a body to the time taken by a body to travel that amount of displacement. In a sentence, you can say rate of change of displacement as a velocity. So, in science, rate means it is a time, rate of change of displacement is called as a velocity. Once again, the SI unit for velocity, dimensional equation of velocity is one and the same when compared to the speed. So, one is speed is a scalar, velocity is a vector. So, you just remember that rate of change of displacement is termed as a velocity. There are many types of velocities you can come across in practice. You can say uniform velocity, variable velocity, average or mean velocity, like that. So, with respect to your syllabus, we can define velocity is broadly into two types. One is the uniform velocity. One is the uniform velocity. I give one small example for this. There is a body, material body, which is under motion. It travels a distance of 60 meters in 60 minutes. A material body which covers the distance of 60 meters in 60 minutes. After in the 60 minutes of its journey, after completing its 25th meter of the journey, what is the distance travelled by it? You can measure. Suppose it is 25 meter only. After 57 meter, what is the distance travelled by a material body? You can measure. Suppose it is 57 meter only. What is the distance travelled by it? After 59 minutes, it is 59 meters only. What is the distance travelled by it after 59 minutes and 30 seconds? Suppose it may be a 59.5 meter only, then corresponding type of the velocity of the particle, you can call it as a uniform velocity. So, you just see for 60 minutes, it travels a distance of 60 meter. For 10 minutes, it travels a distance of 10 meter. For 1 minute, it travels a distance of 1 meter. For 30 seconds, in 30 seconds, it travels a distance of 0.5 meter distance only. If this is the nature of the distance travelled by a material body when it is under motion, then with what velocity that material body moves, you call it as a uniform velocity. So, uniform means it is a constant. So, specific definition for uniform velocity you can say as a body a moving body which is under motion is said to possess a uniform velocity if it covers equal distances in equal intervals of time. I repeat, if it covers equal distances in equal intervals of time, however small the interval may be. You can observe here, we can consider the fraction of a minute. So, here it is a fraction of a minute, for a fraction of a minute it is a fraction of a meter. For 1 meter it consumes 1 minute, for a half meter it consumes half minute. So, if a body is said to possess a uniform velocity, if it covers equal displacements in equal intervals of time, however small the intervals may be. So, if not the corresponding velocity of a moving body, you can call it as a variable velocity. If the velocity of a moving body is not uniform, then corresponding velocity you call it as a variable velocity. So, in the same manner, there is a body which covers a distance of 60 meter by consuming a time of about 60 minutes. So, when the journey start, after completing the 30 minutes, it may travel a distance of 45 meter. 30 minutes it may travel a distance of 45 minutes. So, then in the rest of the 30 minutes, suppose it will travel a distance of 50 meters, sorry. So, for 30 minutes if it travels a distance of 15 meter, then here also for traveling a distance of 60 meter, so it will consumes 1 hour. But it is not uniform. For the first 30 minutes it will covers a larger distance, the rest of the 30 minutes it covers a very smaller distance. But here also 60 meter distance is travelled in 1 hour, here also 60 meters of distance is travelled in 1 hour. So, but here it is not uniform, but in the first case it is very much uniform. So, this velocity is called as a variable velocity. This type of a velocity, so it is called as a uniform velocity. Then how can you define the variable velocity? Means a body is said to possess a variable velocity if it does not covers equal displacements in equal intervals of time. If it does not covers equal displacements in equal intervals of time, however small the intervals may be. So, if a body is said to possess a variable velocity, if it does not covers equal displacements in equal intervals of time, however small the intervals may be, the corresponding velocity you can call it as a variable velocity. So, these are the two very important types of the velocities. One more type you can say average velocity. So, how can you calculate the average velocity? Means it is a ratio from total distance travelled by a moving body to the time taken to travel that amount of total distance. It is a simple ratio, total distance travelled divided by time taken to travel that amount of distance. So, these from the examination point of view also you can expect what is uniform velocity, what is variable velocity. So, if the velocity is not uniform you can say variable, but for uniform you should know what is the definition. It covers equal displacements in equal intervals of time, however small the intervals may be. Now, we came to know if the body is under motion. So, time is a variable quantity, along with it displacement is also variable quantity. When there is a displacement changes, it gives a birth to the definition of a physical quantity, that is a velocity. Now, for a moving body, time changes, so displacement changes, its velocity also goes on changes. So, I mean there is a body which is under motion, its velocity is not uniform. So, that is it moves with a variable velocity. I hope you may understand. There is a material body which is under motion. It moves with a variable velocity. I mean its velocity goes on changes as time passes. Now, the question is there any relation between change in velocity with respect to time? So, definitely it is. It gives a definition for one more physical quantity. It is called as a acceleration. So, what is acceleration? Please note that the question of acceleration arises only when the body moves with a uniform velocity. I mean, with what rate the velocity of a moving body changes when it moves with a variable velocity. So, how can you define the acceleration as? It is simply a rate of change of velocity. So, as I explained earlier, rate means it is a time. In the denominator you can write time, in the numerator change in the physical quantity, that is velocity. I mean, it is a ratio of change in velocity to the time taken. So, it is taken as a acceleration. In a single way, in a single sentence you can say rate of change of velocity is called as a acceleration. So, let us imagine that there is a body which possesses some mass. It travels along a straight line with a velocity say u meter per second. It may be some initial velocity. So, on this moving body some force has been implemented either in the direction of the body or in the direction opposite to the moving body. Definitely its velocity changes. I repeat, there is a body which moves along a straight line with a velocity u meter per second. Now, a force is applied on this body in the direction of the moving body or in the direction opposite to that of the moving body. So, in both of the cases if you apply some forces on it, so there is a change in its velocity. Then the change in velocity by influence of force in a time t seconds, you can call it as a v meter per second. For our convenience you can say u is the initial velocity, v is the final velocity. So, u to v changes in a time t seconds by the influence of a force F. Now, what is the acceleration of this body? Because its velocity changes. So, change in velocity usually we can refer as a difference between final velocity with the initial velocity v minus u divided by t. This is the acceleration. This is the one of the mathematical equation used to calculate the acceleration for a moving body. So, if the body moves with a variable velocity, change in velocity, I mean final velocity minus initial velocity to the time taken, that is t seconds. So, the SI unit of acceleration is, so change in velocity whatever it may be, it is velocity, it is meter per second, again time it is second. So, denominator in the numerator comes to the denominator, s into s, you can say m by s square, meter per second square or meter into second to the power of minus 2. It is the SI unit of a acceleration. As we all know, the dimensional equation of the acceleration is, the dimensional equation of acceleration is 1 in length, 0 in mass and minus 2 in time. So, this is the dimensional equation of a acceleration. So, you just remember that the rate of change of velocity is called as acceleration. Mathematically, acceleration for a moving body is a is equal to v minus u divided by t. Now, while defining the velocity for a moving body, we says that rate of change of velocity, definitely change may be of the two kinds. So, the acceleration attained by a body when its velocity increases, or acceleration attained by a body because of the decrease in velocity of a moving body. There are two chances. So, is the, in both the cases is the definition is same? Definition is same whether the acceleration results with the increase in velocity or decrease in velocity. More specifically, if the acceleration attained by a body because of its decrease in its velocity, then corresponding acceleration you can call it as a negative acceleration. This negative acceleration is called by a specific word, it is called as a retardation. So, it is abbreviated by the symbol minus a. A means acceleration, minus a means negative acceleration. In most of the examination for 1 marks, so you can watch this question, what is retardation, define retardation. In a single sentence you can say negative acceleration is called as a retardation. The negative acceleration results, retardation results when there is a acceleration attained by a body due to decrease in the magnitude of the velocity of a moving body. Negative acceleration is called as a retardation. Again, as that of different types of velocities, acceleration is also broadly divided into 2 types, namely, so uniform acceleration. Uniform acceleration, another one it is variable acceleration. Uniform acceleration and variable acceleration. The definition for uniform velocity and uniform acceleration are one and the same except one basic change. So, the question of velocity means rate of change of displacement. So, the definition for acceleration is rate of change of velocity. While defining a uniform velocity, there is a change in equal amount of displacement in equal intervals of time. Here, in case of a uniform acceleration, replace the displacement by velocity, that is all, there is no much more difference. So, by following that convention, simply you can define acceleration of a uniform acceleration for a moving body as follows. A body is said to possess a uniform acceleration if there is a equal amount of changes in its velocity in equal intervals of time, however small the intervals may be. I mean, change in velocity should be uniform. Change in velocity should be uniform, whatever may be the interval of time, whatever may be the duration of time, whether it is a short interval or a large interval, we never bother. I mean, the thing is the change should be constant. So, you can say the velocity, when a body is under motion, the acceleration possessed by it is a uniform if there is a equal amount of changes in its displacement in equal intervals of time, however small the intervals may be, then corresponding acceleration attained by a moving body, you call it as a uniform. Uniform word itself gives what type of acceleration it is. It is constant. Acceleration means change in velocity. Change in velocity should be constant. That is all. Uniform acceleration means velocity should be changes uniformly, constantly, without any abrupt manner, like that. So, what is a variable acceleration? As I explained earlier, if the velocity acceleration of a moving body is not uniform, then corresponding it is a variable. Then you can expect a question on how can you define the variable acceleration? By making a simple change in a uniform acceleration, you can define it. The acceleration possessed by a body is said to be a variable if it does not, if there is unequal amount of changes in its velocity. In the previous case, there is a equal amount of changes in its velocity. Here it is, if there is a unequal amount of changes in its velocity in equal intervals of time, however small the interval may be. A body is said to possess a variable acceleration. The body is said to possess a variable acceleration if there is a unequal amount of change in its velocity in equal intervals of time, however small the intervals may be. Note that the unit dimension of uniform and variable acceleration are same as that of the original physical quantity acceleration. So, the point to be noted here it is in this corner, if a body is under rest, its velocity should be 0. I mean, the question of velocity arises only for a body which is under motion. If a body moves with a uniform velocity, definitely its acceleration should be 0, because the question of acceleration arises only when the body moves with a variable velocity. Do not get confused. If a body moves with a uniform velocity, then it does not possess any sort of an acceleration. If a body moves with a variable velocity only, then only it has some extent of acceleration. Depending upon what type of acceleration it is, you can say whether it is a uniform acceleration or variable acceleration. So, this is the brief introduction on the few basic physical quantities which are used very frequently in the dynamics. So, depending upon these definitions of velocity, speed, acceleration, different types of velocities and different types of the acceleration, few equations of motion are used, few equations of motions are derived to find the unknown physical quantities for a moving body. With respect to your examination, there is no derivation of these equations of motion only. So, I have to write down those equations of motion. So, you to practice to write those equations. So, first equation of motion is V is equal to u plus at. The abbreviation used here it is u is a initial velocity, v is a final velocity, a is the acceleration assigned by the body, t is the time taken by the body. Then v square is equal to u square plus 2as. Again v, u, a are same as I explained in the first equation. S is the distance travelled by a body in a given time. Then one more equation is S is equal to ut plus half at square. This is also one of the equation of the motion. One more it is S suffix n, which is equal to u plus a by 2 into 2n minus 1. So, S suffix n stands for distance travelled by a body during nth second of its motion. It don't mean that distance travelled by a body. Now the thing is, so suppose